This is the screencast for Lesson 14 in Stephen C# 24-Hour Trainer. This lesson talked about strings, and in this try it, we're going to build an application that displays a string showing the current date and time. This is actually a fairly simple application, so I'm also going to talk to you about a few other aspects of strings which are kind of confusing. So here's our program. Initially, let's add a label to it. I'm going to move the label here. I'm going to center it, and to center it I need to make it so that it's resizable, which means I need to turn auto size off. I'm also going to make it a little bit bigger. Let's go with 12 point. And let's drag it over here. Set its text align property to middle center. So now whatever text it displays will be right in the middle of this label. Let's give it a better name too. We'll call this time label. Now we're going to do all the work when the form loads, so I'll just double click on the form to get into the load event handler, and I'm going to say time label.text equals datetime.now.toString, and then here I'm going to include my formatting string. So I'm going to say it is, and I'm putting it is in quotes because I don't want the format string to try to be interpreted. I don't want the toString to try to interpret it is as a format string. Hour, minutes, and seconds. And then here I'm going to say on, again in single quotes so that toString doesn't try to interpret it. And we're going to do the date, month, day, year. Let's see what that gets us. So now it says it is 11:54. Oh, I messed up here. Don't want the colon there. The TT gives us the AM PM specifier, so I don't want the colon. I could put a space in there if I wanted to. It is 11:55 a.m. on Thursday, April Fool's 2010. That's not really the date. I changed my system clock, so it would be that date for this demo. In general, you want to try not to use customized formats like this, because then if somebody on a computer in a different part of the world runs your program, they may get a result that doesn't make any sense to them. For example, in some parts of the world they list months first and dates second, whereas in others they list date first and month second. So it's better to use the predefined date and time formats whenever you can, but this is good enough for this example. Now, two things I want to mention about strings real briefly. Strings are more complicated than they seem. They seem like a primitive data type like an integer or a float. And they are a fairly basic data type, but they're not that simple. They're actually a more complicated object. The string itself doesn't contain the text that you type. Instead, it contains a reference to a place where that text is stored. In .NET does kind of an odd thing with strings. Strings are what's called invariant. That means if you create a string, you can never ever change it. In your code, it may seem like you're changing it, but you're really not. Instead, what .NET does is it destroys the string you did create, or at least it stops using it so it can be recycled later, and it creates a completely new string. So for example, I'm going to mess this application up now, and this is not part of the try it. If I create a string variable, I'll just call it name, and I set it equal to Rod. I've now, when the code runs, it creates this string with the value Rod somewhere out in memory. Now in the next statement, if I say name plus equals Stevens to add my last name on, it looks like I've just added that text. But really what .NET is going to do is it's going to throw away the old string, create a new one that has the value Rod Stevens, and save it in this variable. Okay? For the most part, you don't need to worry about that. It's transparent to you and it's no big deal. The one case where it really does matter is if you're creating a huge number of strings. So like if I'm going to add to this string a lot, for instance, if I do this, for I equals 1 to 100,000, I plus plus, and I'm just going to say, what is this beef there? We'll go to 10,000, and I say, oops, I know what its beef is. It wants an I less than or equal to Okay. So now I want to do something like name plus equals x. Okay. If this were a simple data type, this would not be a big problem. It would just add a bunch of x's and we get this enormous string full of x's. However, because of the way .NET treats strings, every single one of these things is a separate object. That means we just created 10,000 different objects and destroyed almost all of them. Only the final result, that's the only one that remains after this is all done. And that's pretty inefficient. So what you can do instead is you can create a string builder. And I don't cover this in the text because it's a little more advanced. And for simple programs, you'll never need to use it. But it's a good tool to know about. So I'm going to create a string builder object. I'm just going to call it, I'll call it SB for short, equals new string builder. If you have some guess as to how big your string might get, you can use some of these overloaded methods here. You can put a capacity in to try to give it a guess as to how big it should make the string initially. So in this example, I could make it 10,000 because I know it's going to be a really big string. Now the way you can make this, use the string builder is I can say string builder dot. If you look through here, you can see a couple of key methods. Append is very important. That's the one you would use to add text onto this string. Append line is kind of similar. Append format lets you format as you add on. Length tells you how big the thing is. And there are a few methods like replace where you can replace substrings, and toString will turn it into a string, so when you're finally done to use the thing, you can do something with it. So if I want to do the same thing that I did up here with that name variable, I can say sb.append rod to give it its initial value. If I can type correctly, there we go. Now I can add my last name, sb.append Stevens. And now I can even do that loop for int I equals 1, I less than or equal to 10,000, I plus plus, sb.append x. So that does roughly the same, it has the same effect as the previous code, but it uses the string builder. So what's the advantage? Well, the string builder doesn't handle strings the way the normal string variable does. Instead, it creates a buffer in memory and it manages it more as if it were a big array full of characters. It will automatically resize itself as it needs to, and if it needs to resize itself, it's allowed to add extra space to make room for future additions. So in this example, I don't know the details of how string builder works, but it might add room for 100 characters at a time in here. That way it wouldn't need to resize itself as often. And as I mentioned before, if we happen to know that this thing is going to be around 10,000 characters long, we can start it off that big. When we're finally done building the string, you can say name equals sb.toString, and that will take the string builder, turn whatever it currently contains into a string, so you can put it into a string variable. So as I mentioned, string builder is a little bit more advanced. If you're only messing with a few hundred strings, you're doing a few concatenations here and there, it's not a big deal. It's only when you're dealing with really big strings that this is going to make any difference.